Hey everyone, in the first part of our sequence in the series, you'll be learning about arithmetic progressions. So in arithmetic progression, it's basically in the name, right? Arithmetic, so you're looking at plus, minus, times, divide. But in an arithmetic progression, we're only focusing on the plus and minus. What do I mean? Basically, in an arithmetic progression, the terms either strictly increase throughout the sequence or strictly decrease throughout the sequence. So let's take a look at some examples. The first example being, let's say we have first term 1, next term 3, third term 5, and then fourth term 7, fifth term 9. As you can tell, right, the terms are increasing, and more specifically, two adjacent terms have a difference of 2. Of course, increasing, so the first term to the second term is plus 2, the second term to the third term is plus 2, and so on and so forth. Let's take a look at another example, a counter example, where instead of having it increasing, we have it decreasing. So let's say we start from 15, we become 11, then we get 7, and then 3, and then minus 1. So you can tell, right, it's a decreasing one, and more specifically, decreasing by 4. So we get minus 4 for every 2 terms. So is there a formula for us to find a specific term? There are, right? We can actually find it, right? So let's denote the term in an arithmetic progression as UN, where n is the nth term. So if you notice on the second term, right, of the first example, it's basically adding plus 2 from 1, from the first term 1. Only 1 times plus 2. The third term though, you notice you add 2 times of plus 2. So to put this here, 1 plus 1 times 2, 1 plus 2 times 2, 7 would be the fourth term, and you notice it's 1 plus 2, 3 times 2, 9, which is the fifth term, 1 plus 4 times 2. You notice, right? The one constant one will always be here. So you can, deduce that the generic term will have the 1 in front. So we have 1 plus. The number 2 stays constant throughout, so you have plus 2. All right. Now the number increases, right? Starting from second term is 1, third term is 2, fourth term is 3, fifth term is 4. And you notice that this number is always 1 less than the term number. And if the term number is n here, it will be 1 less, so I get n minus 1 to take as the formula 2n minus 1, which happens to also be the case of all the odd numbers for positive n, or any n for that matter. Let's apply the same logic for the second sequence, right? So the second term, we have 15 minus 4 times 1. Third term, we have 15 minus 4 times 2, because you minus 4 twice. Fourth term, I think you can see the pattern here, right? 15 minus 4 times 3, and I guess here will be 15 minus 4 times 4. Same logic, right? You notice you have 15 in the front, minus 4 is a constant. The difference is that the numbers are now different, right? You have 1, 2, 3, 4, and they correspond to be 1 less than a term number. So similarly, n minus 1, and then you get 19 minus 4n. So in general, all right, let me use another color. So in general, to find the term, the general formula for the term is basically a minus, or a plus, n minus 1d, all right, where a is first term, u1, first term. D is the common difference, all right? So common difference, basically, if you look at the first sequence, is plus 2, so that's the common difference. For second sequence, it would be minus 4, all right? So in summary, in general, for the formula to find a specific term is un equals to a plus n minus 1d. Now let's take a look at what are you able to find a formula for finding the total sum of n terms, basically the series, all right, of n terms. So let's take a look at a very famous example where someone was punished for finding the sum of 1 all the way to 100. And what this smart dude did was, first, you notice that you can take pairs, right? The first and the last, the second and then the second last would give you a sum of 101, 101, and 101. Because you're now taking pairs, right? So you have to take the total number of numbers divided by 2, because pairs are in 2s. Now, you know that the first, then you take the first and the last term. So you're taking 50 pairs of 101, which is basically the first and last term. So from here, you get 50, 50, right? 50 times 101, so 50, 50. That's the whole idea behind the general formula of an arithmetic progression, where we have, instead of un now, we have Sn, the series of n terms. Basically, it means the summation of n terms, of the first n terms. So what the general formula is, the same logic, right? The number of pairs will be the total number of terms divided by 2. Then you take the first and the last term, right? So L is the last term. Because if you recall, right, brief moments ago, we found that un equals to a plus n minus 1d, right? So the nth term will be a plus n minus 1d. Because of this, we know that the last term for a series of n would be the nth term, right? Because you're finding the summation of n terms. So the last term must be the nth term. Therefore, if you sub in the nth term, which is a plus n minus 1d, we have another general formula of 2a plus dn minus 1, and that's the general formula for our series. All right, so let's put that into practice. Let's use the two sequences from just now. We have 1, 3, 5, 7, 9, and then so on and so forth. So we know that the general formula is, for the term, is un plus 2n, un equals to 2n minus 1. So if you look at the summation, all right, basically you have n terms, right? So you get n divided by 2. First term would be 1. The last term would be 2n minus 1. Therefore, over here, you get back n squared. Okay. Another way to do it is basically n over 2. So you use, what I did was using this formula, and I'm going to use this formula here. n2, so you get 2 times a, so the first term is 1, so 2 times 1 is 2, plus common difference 2n minus 1. From here, you get back the same answer, n squared. Okay, now let's look at the second one, where we have 15, 11, 7, 3, minus 1, and so on and so forth. All right, so you can just straight away write down the sequence. All right, so you have n terms, so you take n divided by 2. All right, first term and last term, so you can use either formula. So if you want to use the second formula here, so we have 2 times 15 minus, right, d is now minus 4, so minus 4 and minus 1. All right, so n over 2, 30 minus minus 4, so 34 minus 4n. This would then give us 17n. Well, actually, we can just factorize it out. 7n, 17 minus 2n. All right, now you can use the first formula as well. So let's say I'll use the first formula. Yeah, so the first and last term, right? So I know the first term would be 15. Last term would be 8. Is it 18? 19 minus 4n. Yeah, just now, right? And then you guys, you get back the same answer. So either method works, all right? In general, the second method, you will use the second method more. But if you do have the exact value of the last term, you might want to use the first method as well. All right. So in summary, for the arithmetic progression, we have the following. So the gen formulas. So for the term itself, it would be a plus n minus 1d. For the summation, it would be n over 2 number of pairs, a plus l equals to n over 2, 2a plus n minus 1d. All right, where we have a equals to u1 equals to first term, d equals to common difference, and l equals to the last term of the series. All right, so there we have it, the general formulas for arithmetic progressions.